Hello everyone. So we're going to continue now our lesson. So we ended up with this slide. Okay, liquid pressure head in terms of water pressure head. So let's talk about manometers now. No, I have already introduced this before. Manometer. No, so a manometer is a tube usually bent in a form U containing fluid that is used in measuring gauge pressure or gauge pressure difference. So this is an example of a manometer. Okay, so it is used in measuring gauge pressure. No? So, so as you notice, it is in a form U containing fluid. Okay, so we have another manometer. So this is a manometer wherein it is used to measure the gauge pressure difference. No, so the gauge pressure difference. So there is pressure at A and pressure at B. Okay. So what's the difference between the two pressures? Okay. So given this one, it measures pressure at A. What is the gauge pressure at A? Okay. So this is an open type manometer. Okay. This is a closed type manometer. Okay. Now we have classification of manometers. So as I have said in my previous slide, we have an open type manometer with an atmospheric pressure surface on one leg. Okay, so this is the leg that we consider. Okay, and there is atmospheric pressure. No, so since it is open, air is free to air molecules is free to occupy the space here, no? And with the presence of air molecules, so there will be atmospheric pressure, no? Acting at this surface, okay? Wherein such atmospheric pressure is considered a gauge pressure of zero, no? So there's another type of manometer called differential type, no? So this is without atmospheric pressure surface. Okay? So without atmospheric pressure surface on any leg of the manometer and capable of measuring difference in pressure only, just like this. Okay? This is a differential type manometer. Okay? So it is capable of measuring difference in pressure only. So as you notice, there is no leg that is open to the atmosphere. No? So this is the differential type manometer. Then we have the piezometer. No? Piezometer, we have it's the simplest form of manometer. So it is a tube. No? It is a tube tapped into the wall of a container. So this is our container. Okay, and this container, so there is a tube tapped to it, no? Okay, so the container could be a cylindrical container, no? Okay, so there is a tube tapped to it, and we call this now as the piezometer, which is the simplest form of manometer. Okay, so here are the steps in solving manometer problems, no? So I'm going to teach you on how to solve manometer problems now. So decide on the fluid in feet or meter of which the pressure heads are to be expressed now. So that's the first step. We will decide on the fluid now. So it is convenient if we choose water. Water is most advisable because the specific gravity of water is 1. For a temperature of 4 degrees Celsius, the specific gravity of water is 1. No? So that is the most convenient substance, no? Most convenient fluid. So decide on the fluid in feet or meter. So in that case, we will uh, consider pressure head for water, no? Pressure head for water. And we are to decide whether we are to express that pressure head in feet or in meter or in any unit that we like, no? Depending on the problem. Next step is to start from an endpoint. Okay, so we will start from an endpoint in the manometer. So later I will show you what endpoints mean, no? Endpoint here mean, no? So I will discuss this in detail when we have an example. Starting from an endpoint, number in order the interface of different fluids. Okay, so a number in order the interface of different fluids. So later I will show you how with an example. Then the third step is to identify points of equal pressure. Okay, taking into account that for a homogeneous fluid at rest, the pressures along the same horizontal plane are equal. Okay, so the pressure along the same horizontal plane are equal. Now, so label these points with the same number. Then the fourth step, proceed from level to level, adding if going down or subtracting if going up. Now, adding pressure heads, we will add if going down, we will subtract if going up. Now, as the elevation decreases or increases, respectively, with due regard for the specific gravity of the fluids. Okay, so let's answer an example so that we will apply these steps in a certain example. No? So let's do it now. So here's a problem. Find the pressure at M to be measured by an open manometer shown. So this is our manometer and we are to determine the pressure at M. Okay? The pressure at M. So what is that pressure at M? Okay? Now fluid A is oil. So this is oil having a specific gravity of 0.80. No? So the specific gravity of oil is 0.80. For fluid B, mercury, the specific gravity is 13.6. Then Y is 30 inches. No? So this is 30 inches. This is 10 inches. Okay? So here it is. So this is 30 inches. This is 10 inches. Okay? Then the specific gravity of oil, which is fluid A. The specific gravity of mercury, which is fluid B. Okay? Now take note that we will uh, apply the steps. So let's recall the steps now. So let's recall the steps. Decide on the fluid in feet or meter, of which the pressure heads are to be expressed. Water is most advisable. So in this case, so we will choose water to be our reference, no? Our reference liquid, no? So we will express the pressure head H of water in unit, either in feet or meter, or any unit that we like. No? So in that case, it depends upon the given in the problem. So let's come back. So as you notice, um, the measurements for y and z, okay, are in inches. So it is convenient if we will express it in terms of inches. Our pressure head. Pressure head in terms of inch. No? Okay? So these are the pressure heads of the following. No? So there is y and z, okay, as considered as heads. No? So so later, no, this will be converted to water, no, in terms of height of water or pressure head of water. Okay, so let's apply step 2. So first step, okay, this will be our pressure head. Okay, we choose water and with the unit of inches. This is for step 1. Okay, with the unit of inches. Okay, step 2. Starting from an endpoint, number in order the interface of different fluids. Okay, here it is now. So starting from an endpoint, this is an endpoint of a certain fluid, okay, and we name it as 1, point 1. Another endpoint, so first endpoint, second endpoint, okay. So this is the interface of mercury and oil, okay, this one. So this is now our second point, okay, this interface, okay, and then until we reach M, okay, until we reach M, so up to here, okay, so this is the third point at point M, okay, so that's point 3, okay, so we applied step 2. Step 2, starting from an endpoint, number in order the interface of different fluids. Okay? Next, identify points of equal pressure. Taking into account that for a homogeneous fluid at rest, the pressures along the same horizontal plane are equal. Label these points with the same number. Okay? So, identify points of equal pressure. Okay, so let's see. Let's apply. So, as you notice, okay, so this is point 1. So this is point 2. Okay, same as here. This is also point 2. Okay, So this is point 2 and this is point 2 with the same level. Okay, so let's come back. Identify points of equal pressure. Okay, if they are at the same horizontal plane, their pressures are equal. No, the pressures along the same horizontal plane are equal. Okay, label these points with the same number. Okay, so we have here, if this is point 2, this is also point 2. Okay, and this is also point 2. Okay, this is also point 2. There. No. So they are at the same horizontal plane. They have now, they are at the same level. So we have the second level. No. So note that the pressure at M, okay, we have the pressure at M is the same as the pressure at point 3. Okay, take note of that. And recall now that in step 4, proceed from level to level, adding if going down or subtracting if going up. Pressure heads, adding or subtracting pressure heads, adding if going down, subtracting if going up. So we add if we go down, no? That is plus H. Okay, adding pressure heads. Plus H if going down, minus H if going up. Okay, because as we go uh, as we go down, the pressure intensifies, right? The pressure will intensify as we go down. As we go up, the pressure is reduced. Okay, the pressure is reduced. Okay, so we continue. All right, so we have plus H going down. Okay, going down. Then minus H going up. No, minus H going up. Okay, so that is for the fourth step. Okay, if we go down from level 1 to level 2, that is plus H. If we go up from level 3 to level 2, that is minus H. Okay, now this will now be the equation applying step 4. So we have here the height of water at 4 degrees Celsius. Okay, we considered pressure heads of water at 4 degrees Celsius. So meaning from level 1 to level 2, from point 1 to point 2, okay, so that's the pressure head of, this is the pressure head, so this will be converted to pressure head of water. No? The height from the distance from 1 to 2 will be converted to pressure head of water. Okay? So that will be converted to pressure head of water. Next, from point 2 to point 3. Okay? Now, take note that we start from 1 to 2, then from 2 to 3, the substance is still mercury, right? 2 to 3. Then, from 3 to 2, it is still mercury. No? 2 to 3, then we go up from 3 to 2, that is minus. So they will cancel. Okay? They will cancel. Because it's the same liquid. Okay? Which is mercury. And then, meaning this is the same substance. So what is next? So this level, this point is also this point. Okay? So this is also 2. So that's why we now proceed from 2 to 3. Okay? From point 2 to point 3. So we add that. Plus H23 in terms of height of water at 4 degrees Celsius. Okay? And we will end up with H13. So that is the height from 1 to 3. Okay? The height from 1 to 3. Alright? So, recall that the height of water at 4 degrees Celsius is equal to the product of the specific gravity of a certain fluid multiplied by the pressure head of it. And recall the pressure head formula that it is equals to the gauge pressure over the specific weight of that fluid. No? So applying that, we have this formula. We have this equation. So we have the specific, so H12, no? So we have H12 of water. Okay? So H12 of water. H12 of water. Okay, at 4 degrees Celsius. So that is equals to, so that is the specific gravity of the substance. So from 1 to 2, the substance is fluid B. So that's why we have SGB times Z. Now because from 1 to 2, so the fluid is fluid B, which is mercury. Okay? So H12 is the specific gravity of fluid B multiplied by Z of 10 inches. Okay? Multiplied by Z. So that's the pressure head. That's the height. Okay? The height of fluid B. Okay? From 1 to 2. Next, we have H23. So H23 is SGA times Y. Okay? H23. So we proceed now at this level, then going down from 2 to 3. No? So from 2 to 3, the fluid is oil. That's why we have SGA multiplied by Y. Because from 2 to 3, that is equals to Y, which is 30 inches. No? Applying this formula, SG1H1. Okay? And then, the height from 1 to 3, the height from 1 to 3 is simply the pressure head at M. That is simply the pressure head at M. This is already HM. No? That is already the pressure head at M. So that's why we have this formula. The pressure head at M, okay, so from 1 to 2, then from 2 to 3. And that is equals to the pressure head at M. Okay? And the pressure head at M is given by this equation. No? So we have this equation now. Pm over unit weight of water at 4 degrees Celsius. Because of this formula, P over gamma. So P sub m over specific weight of water, because water is our substance that we consider. Okay, so that's it. No, next we proceed. So we have here, it repeated. No, it repeated. So we have now unit weight of water at 4 degrees Celsius. Okay, we arrange the equation. So we multiply this to this one. Okay, so to obtain the pressure at M. Okay, next we substitute. So we have unit weight of water at 4 degrees Celsius. That is 62.4 pounds per cubic foot. No? Okay, then the specific gravity of liquid B is 13.6 multiplied by 10, which is expressed in inches. Okay, plus 0.80, the specific gravity of liquid A, 0.80 multiplied by y, that is 30 inches. Okay, so I already factored it out, so kaya may inch doon. Okay, so we will express this to psi. So let's multiply it by, let's convert cubic foot in terms of cubic inches. Okay, that's why we have the conversion. For every cubic foot, okay, cancel, cancel. That is 12-inch cube. No? 1 foot is 12 inches. So 12 inches cube, that is 1 cubic foot. So we have pound inch over cubic inch. No? Excuse me. So we have now pound per square inch. Pounds per square inch. So that's why we get 5.78 psi. Okay? I hope you get it. So we can proceed. Or you can indicate G, okay, instead of 5.78 psi, you can be specific, that is 5.78 psi gauge. No? So here's the second problem. For a gauge pressure at A of negative 10.89 kilopascal, find the specific gravity of liquid B. No? So we are going to determine the specific gravity of liquid B. So the pressure at A is negative 10.89 kilopascal. So what's the specific gravity now of liquid B? So for the solution, okay, applying the steps. So we have the first level. Okay, this is point 1. Okay, another level at this is at point A. Okay, another level at point 3. Okay, another level at point 4. Okay, so next, take note that at this level is the same as this one. Okay, so same pressure at this level, and then at this level same pressure as this one, no? Which is also at this level, level 4. Okay, So same as this one. They are on the same horizontal plane. No? So recall, plus h going down minus h going up. So this will now be the equation. So we started from here, no? From this endpoint, point 3. Okay? We started at point 3, no? So if we started from point 3, so this is the fluid, which is liquid B. So we have 3 going down, then going up. So that will be neutralized, no? So that will be neutralized. Okay, going down, then going up. Then we start from here at the same level. So going up now from 3 to 1. So if we go up, the sign will be minus. That's why we have minus H31. Take note also that we chose water to be our reference fluid, our reference liquid. Okay, it doesn't matter whether the fluid is water or not in this uh, in the given manometer, not the fluid in the manometer. It doesn't matter whether there is water or none. No, what is important is our solution. We are to express the pressure heads in terms of pressure heads of water. No, so in here from 3 to 1. So this is pressure head for liquid B, and that will be converted to pressure head of water at 4 degrees Celsius. That's why we have minus H31. Minus H31. Then we have this part which is air. Okay, so at this interface, okay, at the same level, this is also point 1. And from point 1 going to point 4. So we will go down. That's why we have a positive sign, a plus sign, from 1 to 4. 1 going to 4. No? 1 going to 4. So plus each one 4. Okay? Next, so same at this interface. So going down, then going up. So we have this level at this point, point 4, from 4 to 2. From 4 to 2 going up. So there will now be minus sign. Minus H for 2. From 4 to 2. And we stop there. At point 2, that is the pressure that is considered as the pressure head at point A. No? That's why we have equals H sub A. No? We stop here. So at the same level, so in other words, that is equated to the pressure head at A. Now, we proceed with the next step. So, recall that the height of water at 4 degrees Celsius, or the pressure head of water at 4 degrees Celsius, can be obtained by multiplying the specific gravity of a certain liquid to its pressure head. No? So, also, the pressure head formula is simply pressure over specific weight. So this will now be the corresponding equation. So we have H31, okay? So by formula, no? Since that is H31. So, from 3 to 1. From 3 to 1. Okay, the substance is liquid B. That's why we have minus SGB. Ito, SG1H1. So, we have SGB for liquid B. H1. So, that is H31 for liquid B. H31 for liquid B. Okay? Doing that, that will now be converted to pressure head of water from 3 to 1. Then plus H14. Okay, from 1 to 4, the substance is air. So the pressure head is 0 because air here is considered atmospheric pressure. And for atmospheric pressure, the gauge reading is 0. No? The gauge reading is 0. So, H14 is considered 0. No? 0 pressure head. Okay? Because there's no pressure. There's no gauge pressure. So, this is the formula. The gauge pressure over gamma of air. But the gauge pressure is 0, no, for air. Okay? So 0 over gamma for the specific weight. So that's why the pressure head is 0. Next, H42. So we have H42 from 4 to 2. The substance is liquid A. So we have SGA H42A. Okay? So equal to, so after that, equal to HA. So that is equals to HA. And HA is equals to the pressure at A over the specific weight of water at 4 degrees Celsius. Okay? So this will now be the equation. So we transpose, no? So we transpose this to the right. Then we divide by H31P, including the sign. Okay? So next, so we have the pressure at A is negative 10.89 kilonewton per square meter. No? So our target is to determine the specific gravity of liquid B. So this will now be our equation. No? So negative 10.89 kilopascal over 9.81 kilonewton per cubic meter plus 1.60 for specific gravity of liquid A multiplied by H42A. Okay. So H42, what is this height? No? What is this height? So there's elevations. Elevation at 4 and elevation at 2. So we just subtract. No? That is 3.2 minus 2.743. No? So 3.2 minus 2.743. Okay? So that is the formula. No? So we have here H42, no? 3.2 minus 2.743. Okay? So this is elevation 0 for example. Okay? So this is elevation 0. Okay? This is elevation 2.743, right? And this is this height is 2.743 meters. No, then this height is 3.2 meters. No, okay. That's why we get the difference 3.2 minus 2.743 to obtain this height. No, okay. The pressure head at that point. No, so the pressure head from 2 to 4. No, that will be expressed in terms of pressure head of water. Okay, and then we divide it by negative. Okay, we have H31B. Okay, so H31B. So we have H31B. We have here. So liquid B. So that is from 3 to 1. So we get this height. No, this is H31B. So that is simply elevation, higher elevation minus lower elevation. So that is 3.429 minus 3.048. That's why we have that. Okay? 3.429 minus 3.048. And what will now be our final answer? No? Our final answer is 0.9945. Okay? So, specific gravity is 0.9945. So, syempre, dapat consistent tayo sa unit. No? So, kilonewton per square meter over kilonewton per cubic meter. Ang matitira ay meter. No? Matitira dito ay meter. Tapos plus meter over meter, cancel. No? Kaya unitless. So, next, number 3. Find the pressure difference between A and B for the setup shown. Okay. So, differential type manometer naman tayo. So, required pressure difference. No? So, this is level 1. This is level 2. Okay. Level 4, level 3. No? Okay. Now, solution. So, tandaan nyo interface, interface. Okay? Solution. Recall, past last h going up minus h going down. So, ito yung equation natin. So, we start with an endpoint. We can begin at the bottom, then going up. So, pwede natin piliin, umpisan dito, HA, pressure head at A. That is in terms of water. Then, going up from 4 to 3. Okay. Going up minus. Then, from 3 to 1. No? This is 1 also, right? That is 1, this is 1. From 3 to 1. Okay? Minus ulit. Next, from 1 to 2. No? Kasi yan ay 2 din, di ba? From 1 to 2. Water na yon. So, H1, 2. Plus nun. Kasi going down na nun. No? Then, equals to HB. No? The pressure head at B. Okay? So, we consider water. Okay? So, recall that the height of water is SG1 times H1, no? Height of water at 4 degrees Celsius, no? And the pressure head is simply P over gamma. So this will now be the equation. Okay, pressure at A, okay, for the pressure head at A, no? Kasi hinahanap is PA minus PB eh. So we are to express HA in terms of PA, no? So PA over unit weight of water, okay, minus Y. So, bakit Y lang? H43. Ba't wala na yung SG0, H310? Ba't walang ganon? Kasi water na yan eh. Diba? Ano specific gravity ng water? 1. Ano yung height? Kung anong height ng water na nandito, edi Y. Kaya 1 times Y is Y. Okay? Or simply, sulat mo na lang Y. From 4 to 3. No? And then, from 3 to 1, from 3 to 1, oil yan, oil. Kailangan i-multiply yung specific gravity ng oil sa kanyang height, no? Sa kanyang pressure head. So, oil, specific gravity times H31 sub 0 sub O, no? So, this is 1. Okay? So, and then, H12, from 1 to 2, water ulit. So, X na lang isulat mo. Water ulit eh. X. Okay? No need to write the specific gravity kasi 1 naman, di ba? So, sabihin, ang H1 natin dito ngayon ay X. Okay? So, yun ay X. From 1 to 2. So, equals to the pressure head at B. Okay, which is pressure at B over the specific weight of water. Ito yan. Applying that. So, this will now be the equation. So, ayusin lang natin. Transpose natin. Okay. Kasi target natin PA minus PB. So, ito yung matitira. Transpose. Y. Transpose. Ito. Transpose. Yun. Okay. So, this will now be the equation. So, multiply both sides by the specific weight of water. So, ito yung magiging equation natin. Okay. And then, we take the absolute value of both sides. No? We take the absolute value of both sides. Kasi, pressure difference eh. So, sabihin yan, disregard natin yung negative sign. No? So, kaya we take the absolute value, pressure difference. So, take note that may problema tayo. Wala tayong Y at wala tayong X. Pero wag magkalala, meron naman tayong figure. So, ang Y plus 0.7 meter ay katumbas ng X plus 1.5 meter. Right? They are equal. No? Y plus 0.7 equals X plus 1.5. So, tapos, transpose natin yung X sa left. Y minus X equals, transpose natin yung 0.7 sa right. So, magiging 0.8 na lang. 1.5 minus 0.7. So, this is now 0.8. So, sabihin yan, unit weight of water, 9.81 kilonewton per cubic meter. This is at reference 4 degrees Celsius. Y of y y minus x, no? Y minus x ito. Y minus x. So y minus x is 0.8. Kaya 0.8 meter. Tapos SG0, H310, yung oil 0.8, yung H31 ng oil 0.7. Okay? So we will get an answer of what? 13.34 kilopascal. So that's the pressure difference, no? So that's all. I hope you get it, no, class? We'll see you again. Good day, everyone.